Hi, and welcome to today's lesson. Today we're going to talk about the atomic structure, and this lesson overlaps in 3 subjects. So whether you're doing physics, chemistry, or integrated science, you will be looking at this lesson as the first lesson in atomic structure. Now the lesson is quite short. It's just a basic introduction to one of the founding lessons for understanding atomic structure. So it's very important that you understand what is happening in this lesson. And there's a lot of definitions to learn and a lot of examples and a lot of, as you will see, you have to learn the first 20 elements of the periodic table. Right? So as we go through the lesson, you will understand more about what you should be able to do, and we'll have some practice. Of course, at the end of the lesson, you will have a quiz. Now, a reminder is that you need to have your notes printed, and you need to look at the lesson, pause during the lesson, and take down any extra notes that I write in this video. Alright? So, let's get started. Now, let's look at the molecular view of elements and compounds. Now, in nature, we have pure substances and we have impure substances. In this lesson, we'll be looking at the pure substances, and these can be split into 2 groups called elements and compounds. Okay, so under elements, we have atomic structure, we have atoms, we have molecular structures, and in compounds, we have molecular as well, and ionic structures. Okay, and we have examples of each. So an atom, as you would see here in the notes below, what an atom is. So an atom or atoms are the basic building blocks of matter. Now remember, matter is anything that has mass and volume. Alright? Or the definition for matter is anything that occupies space. Now you learned the definition for matter in the lower forms, and you also learned the 3 states of matter. Alright? Now an atom is the smallest identifying particle of an element that has the properties of that element. Okay? So if we look at the definition of what an element is a specific element that is made up of only one type of atom. Right? Now the elements can combine with each other to form molecules. Elements can be classified into metals and non-metals. Alright, so let's take a look at an example here. So an atom could be something like an oxygen atom. Oxygen exists in nature as 2 oxygen molecules joined together. Alright, so an atom would be one of these molecules by itself. Okay, so it would have been one molecule. An element is made up of only one type of atom, which is this oxygen atom here, but it's more than one, so it's 2 oxygen. Alright, so here is an example, oxygen, which we could write chemically as O2. Okay, so a molecule now, it consists of 2 or more atoms of the same element, or it could be different elements. Now they must be chemically combined. Right? Chemically combined mean they cannot be separated by any physical means. For example, if we filter it, we can't separate the elements. Right? We can't separate the particles. So unlike an element in this circle here, where we have the same type of atoms making up that element, in molecules, we could have the same thing, right? So this is also a molecule, but this here cannot be called an element. It's only a molecule because we are seeing this red atom here and we're seeing white atoms there. So it's made up of different elements and they are chemically combined. For example, water. If I were to filter water, I can't separate the hydrogen atoms and the oxygen atoms that make up water. So I can't do that. So a compound, if we look at this table here again, compounds could be molecular or ionic. Alright, so a compound consists of 2 or more different elements that are combined chemically. the compound has properties that are different to each of the separate elements, and they cannot be separated by physical means. Right? So here, for the example, sodium and chlorine. Sodium and chlorine here are joined together chemically to make this compound here called sodium chloride. Now, sodium chloride is made up of two atoms, sodium and chlorine. Okay, now chlorine is usually a gas and it's very poisonous, it's toxic. We use chlorine to make things like bleach to wash clothes with or to clean surfaces with. Right? Now when sodium and chlorine are joined together chemically, they form sodium chloride, which is perfectly harmless. It is actually the salt we use to cook with. Okay, so this is what we mean by a compound. The compound consists of two or more different elements. So we have sodium and chloride, right, which are two elements. They are chemically combined, and the resulting compound, has properties that are different to each of the separate elements. Okay, so whereas chlorine here would be very poisonous by itself and toxic, when it's combined with sodium, the properties are different. It's perfectly harmless. We use it to cook with. Alright, now too much sodium chloride will send up your blood pressure and cause heart problems, etc. But sodium chloride itself is harmless. Right? It's actually table salt. Now I'll write table salt here. Alright, just as a reminder of what sodium chloride is and how the property of this compound is completely different to each individual component. For example, chlorine, which is toxic. Right? Now, mixtures are made up of two or more substances that are not chemically combined. There are two types of mixtures, and we call them heterogeneous and homogeneous. These can be separated by physical means, and physical means being we could separate them by some sort of filtration method, right? Or any other physical separation means. For example, if I put marbles in sand, I can use my hand and pick out each marble from the sand, right? If I have a mixture of sand and water, like on the beach, we could separate that by filtration. Okay, so these substances called mixtures are not chemically combined. They could be separated. For example, if I wanted to separate sugar from water, I would evaporate the water from the sugar and crystals would remain. Okay, they are not chemically combined. So that is what mixtures are. And in the lower forms, you would have learned what heterogeneous mixtures are and what homogeneous mixtures are. Right? If not, if you did a lesson with separating mixtures, you would have seen and understood what these are. Right? So, we have our differences between atoms, elements, molecules, compounds, and what mixtures are. Alright, so let's look at page 2 and we'll talk about subatomic particles. Now, we're going to focus mostly on atoms here and the atomic structure. We're not going to look too much at elements and compounds and mixtures in this lesson. We're just going to focus on that first column here, the atom. Alright, now these are the basic building blocks of matter. It is the smallest part of an element. Okay? Now atoms, they are made up of 3 subatomic particles. Right? Now you might be wondering, okay, if atoms are the smallest part of an element, why we have smaller parts in the atom? Well, protons by themselves, neutrons by themselves, and electrons by themselves cannot be used to identify a particular element. Alright? We must have all of those together combined, called an atom, to identify what particle or what element is that. Okay? So, if we go into on another planet or in space and we come across a new element, Alright, we would look at its protons, neutrons, and electrons to identify what it is. The protons of these atoms are positively charged, and the neutrons of the atoms have no charge. So, the protons and neutrons are found in the center of the atom called the nucleus. So, I've drawn here my nucleus, and in here, I'm going to put my P for protons, and I'm going to put a N for neutrons. Alright, so I have my protons and my neutrons. And this is at the center of that atom. Now the electrons spin around this nucleus at different levels, and they orbit this nucleus. So they go around the nucleus. Alright, they orbit around this nucleus. And I'm going to use these little X's here to show my electrons. Okay. Now the first shell of this electron always has 2. Okay. It can have 1 or it can have 2, but the maximum must be 2. You can't have more than 2 on that first shell. And you will learn about that in later lessons. Right? So we wouldn't dwell too much on this lesson about that. Now, here is my nucleus. I'm going to label this my nucleus. Okay, so this at the center is my nucleus. And then I have my protons and my neutrons in my nucleus. So this little P here are my protons, and these are going to be my neutrons. I'm going to label that for you. So be sure to pause the video and take down this little diagram. And also any other notes you want to take down from the lesson. Right, as we say, the protons are positively charged, right? And we have here our energy shells. Okay, and these little crosses are going to be my electrons, and we said the electrons are negatively charged. Okay, so feel free to pause the video and draw this diagram. Of course, you could use something to draw these circles a little more circular. Alright, you could draw them freehand. So be sure to correctly label each part of the atom. Right, so this is the structure of an atom. Alright, so our diagrams must have a title. Now let's look at the charges of each of these subatomic particles in the atom. So as we said above in the note, our protons have a charge. It has a positive charge, and the mass of a proton is said to be 1. A neutron has no charges. It's neither positive or negative. It's just neutral. It also has a mass of 1. Now, relative mass here, we would look at that on the other page. Electrons have a charge of -1, so it's a negative charge. And it has a mass of less than 1. As we could see, it's 1 divided by 1,836. Some textbooks or some teachers may round that off for you and say that the mass is 1 over 1,840. Okay, so either this value or this value can be used. Now let's look at the atomic number. The number of protons in the nucleus of one atom is called the atomic number. So here we said we had protons in the nucleus of an atom. The number of protons is called the atomic number. The atomic number is unique to a particular element. No two elements in the world have the same atomic number. If two elements have the same atomic number, it is the same element, right? It's not different. For example, the atomic number of hydrogen is 1, and all hydrogen atoms have 1 proton in them, right? The number of electrons in an atom is equal to the number of protons in an atom. So an atom in nature, its protons is going to equal to the number of neutrons. Its protons is equal to the number of electrons in that atom. Right? So in this diagram here, my number of electrons is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 electrons here. So my proton number here would be 10. So we're going to look at that here. And we will talk about mass number. Now the sum of the protons and the neutrons in that nucleus make up the mass of the atom. Right? The mass number is equal to the protons plus the neutrons. Makes sense, right? Sum means to add. Protons is equal to the mass number minus neutrons. So here from this main formula, if we wanted to find the neutrons or the protons, it would be the mass number minus the protons or the neutrons. Right? So that's what these three formulas here are. It's the same formula derived from this first one. Nuclear notation. Now we can represent an atom or an ion. Now ion here, we will talk about this in later lessons. So don't need to worry about what an ion is. And we represent them using nuclear notation. So here in this notation, we have X, which is the atomic symbol. We have the letter A to represent the mass number of this atom. And Z represents the atomic number of that atom. Okay. So it will become a little clearer when we start to fill out this table here. Now for your practice and to learn, we are going to complete this table to find the mass number, the number of protons, the number of neutrons, and the electrons of these elements. Now, I have 20 elements listed here on page 3 and on page 4. So, you need to learn these first 20 elements in this specific order by heart. Alright, you need to memorize the names, the symbols, and their proton numbers. You do not need to memorize the mass numbers. Alright, just the proton numbers and the name and the symbol used for these first 20 elements. Now, let's look at a periodic table. Okay, so in your own notes, you would see this diagram. You could easily turn your page to the side. Right, so I flipped this here so we could take a look at this. Now, this is the periodic table. You're only required to memorize the first 20 elements. Okay. So the first 20 elements start here at 1. Right, our proton number here is 1, which is hydrogen. 2 is across on this side, helium. 3 is lithium. 4 is beryllium. And we are going in this order. So we start here, we went there, we come back on this side, and we're going across. And then when we reach the end at neon, we are coming back here with 11. Now they are listed in order. So we are just going to look at the atomic proton number. So we have 1, 2, we have 3 here, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and which is where we have to stop. Right? So we need to memorize these first 20 elements here. Alright, those first 20. So what some students do to help them memorize the first 20 elements of the periodic table is that they take the first letter of each element and they make a mnemonic with it. Alright, so they take the first letter and they make either a sentence or something that a rhyme maybe, okay, with the first letters of the elements, and they make a sentence with it, and they learn it that way. Okay, so some students make up a song, some students just learn it 5 at a time: hydrogen, helium, lithium, beryllium, boron. Okay, they just learn it all 5 at a time every day, and you will have all 20 elements in your memory. Alright, now let's look how we're calculating these mass numbers. So with the formula above, I'm just going to bring this formula to the side here so we can use it. Now I'm going to do these first few elements on this page, and your assignment is to complete the rest and submit it. Alright, for me to check. So for hydrogen, we said that the Z is the number at the bottom and it's the atomic number, and A is the mass number. So let's state the mass number. We see here that the mass number is the number on the top, which is which is 1. Alright, so the number at the top is 1. So my mass number is 1. So let's find the number of protons. So as we said above here, the number at the bottom, X, is the atomic number. And we also said the atomic number on the other page here is the number of protons. Z here is the atomic number or the number of protons. Okay, so my number of protons is just this number at the bottom here, which is 1. Right, now my neutrons is A minus Z. So the mass number here is A, so be sure to put in this A in your table. And the neutrons is going to be 1 minus 1, which is 0. Now we said in our note the electrons is the same as the number of protons. So the number of electrons in my hydrogen is going to be just 1. Right? Now let's look at helium. Helium, the mass number is at the top. So my mass number here is this 4. The number of protons, Z, is a number at the bottom here, which is 2. The number of neutrons is going to be A minus Z, or the mass number minus the number of protons, which is 4 minus 2, which is 2. My number of electrons, according to the note, is the same as the number of protons. So my electrons would be 2. Let's do lithium. Lithium, the mass number is 7. This number at the top. The protons is the number at the bottom, which is 3. The number of neutrons is 7 minus 3, which is 4. And the number of electrons is the same number as the number of protons, which is 3. Alright, are we seeing a pattern here? 1, 2, 3, not yet. Alright, let's continue. The mass number for beryllium is the number at the top, which is 9. The protons will be the number at the bottom, which is 4. Your number of neutrons is going to be 9 minus 4, which is 5. Electrons is the same as the number of protons, which is 4. Boron, my mass number is 11. My protons is the number at the bottom, which is 5. Neutrons are going to be 11 minus 5, which is 6. And my number of electrons is going to be the same as my number of protons, which is 5. Carbon, the mass number is 12. The number of protons is the number at the bottom here, which is 6. And the number of neutrons are going to be 12 minus 6, which is 6 as well. And my electrons are going to be equal to my number of protons. So here we have a pattern being formed. Alright, we have 1, 2, 3, 4, 5, 6. Right? Number of protons came from the number at the bottom here. And the mass numbers here, they increase as well, but they follow no specific pattern. Alright, there is no specific pattern. The number of neutrons is the same, right? We have no specific pattern, which we could guess what the number of neutrons are. We could only find them by subtracting from the mass number, by subtracting the protons from the mass number. And the number of electrons is the same as the number of protons. You would see the number of electrons change when we combine them, but those are in later lessons. Okay, but for now, the first 20 elements, the electrons are equal to the number of protons. So, for your assignment, right, so this is your assignment. You're going to complete this table, and you are going to submit your completed table in the classroom for me to check. Right, so submit the completed table. Right, so that's your assignment for this lesson. So it's pretty short, but there are things that you need to memorize. Okay, so continue your calculations. Alright, from here, state your mass number, state the number of protons, your neutrons, and your electrons. So let's look at the atomic mass. Now, the atomic mass is also called the relative atomic mass. This is because the average mass of atoms is found by comparing it to 1/12 to the mass of carbon-12 atoms. Right? Now, if you did my measurement classes, you would learn about how measurement came about and how we measure something by comparing it to something else. So, if you were to measure the length of your laptop using your hands, you could measure it and say, okay, my laptop is maybe 2.5 hands. That's a measurement. We are measuring it relative to your hands. If you use your ruler, you could say, okay, my laptop is about 15 centimeters long. You are measuring your laptop relative to the measurements on that ruler. Right? So same thing with anything that we measure. It's always compared to something else. And we use carbon because carbon is very abundant in nature. We are made of mostly carbon atoms. Right? Plants made up of mostly carbon atoms. So they use the carbon atom to measure everything else off of it. So atomic mass is also called relative atomic mass because the average mass of atoms is found by comparing it to 1/12 of the mass of carbon-12 atom. Later on in the lesson, you would see that we have something called carbon-14 as well. So complete this table here, submit it in the classroom or wherever you need to submit it to for me to correct it, to make sure that you have them in the proper order. And then you would need to learn of your elements, your notation, the symbols for them. Okay, and you need to learn the atomic number. Usually you could count on your finger what atomic number it is. So after you memorize them, you could say them like hydrogen, helium, lithium. You would know that lithium is the third one, so its proton number is number 3. Okay, so learn the names and the symbols, and by extension you would know how to find the proton numbers of these elements. Okay, so that's it for this lesson, and I will see you in the next lesson.